Chapter The Stimulus Generation Creating Using Sequences. How to create and use a sequence. Sequences are made up of several data items, which may form an interesting scenario. For example, you can have a sequence that performs register, read, and write to all the registers within the design. A sequence to perform reset, or another one to supply some stimulus for the duty. So you'll end up having a number of different sequences that perform different tasks to verify a different aspect of the design. Remember that a sequence item refers to a packet of data, while a sequence is just a container for an arrangement of items, subsequences. Now you have a few options. Use 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 existing sequences to drive stimulus to the duty individually. Combine existing sequence to create new ones. Perform reset sequence followed by register, read, write followed by FSM state change sequence. Pull random sequences from the sequence live and execute them on the duty. Sequences can do operations on sequence items or kick off new subsequences. Execute using the start method for a sequence or UVM underscore D or do macros. To execute sequence items by start underscore items and finish underscore items or UVM do macros. UVM do macros will identify if the argument is a sequence or sequence items and will call start or start underscore items accordingly. Sequence can run multiple items of the same type. Use start underscore items, finish underscore items, or UVM do star macros. Sequence can spawn a multiple subsequences. In the case, use start method or UVM underscore star macros. In this page, we will try to execute a uh, sequence item using the start underscore item and a finish underscore item task in order to create a user-defined sequence. Derive from the UVM sequence base class with a specified data object type. Register the sequence with the factory using UVM underscore object underscore utils. Set a default sequencer that should execute this sequence. Call the main stimulus inside the body task. Let's look at an example next. Note the following from the example above. This sequence has been derived from UVM sequence with the data object type myData. This sequence is specified to execute to mySequencer using the macro UVM underscore declare underscore p underscore sequencer. Main task body contains the code to drive the stimulus to the driver. There are two additional tasks, pre-body and post-body, that can be included but optional to perform some tasks before and after executing the body. When a sequence has started, always raise a flag objection to let the test bench know that it's still active. This flag and objection should be lowered when the sequence finishes so that the test bench can finish the simulation and exit gracefully. If the flag is now raised, there are chances that some other component in the test bench called a simulation exit and the sequence will be exited abruptly. You may also place it You may also place it in the body task. The data objection will be randomized and sent to the driver by start underscore item and finish underscore item. In the future, in the figure, sequencer executes the sequence and sends data to the driver. Let's make a simple sequencer to execute the sequence above. Remember to set default sequence to the space sequence. Alternatives: use UVM sequencer. If you don't want to create a new sequencer class and instead prefer to use UVM underscore sequencer, you can do so by substituting the appropriate lines. This will create a sequencer of type UVM sequencer that can operate on data my data instead of the user-defined custom sequencer from example above. The class basic above. And next is use UVM sequence utils. Another way to accomplish the same task is to use macro UVM underscore sequence underscore utils for the sequence and UVM sequencer utils for a sequencer while registering with the factory. Remember to call the UVM underscore update underscore sequence underscore live underscore and underscore item macro to update the database. This macro may be deprecated in the future. Simulation log. Next is here UVM how to use UVM underscore do sequence macros. In how to create and use a sequence, we saw that a sequence calls on the tasks, start items, and finish items. You can avoid putting all these statements in your code by simply calling UVM sequence macros UVM underscore do or UVM underscore do with. At a compile time, these macros will be substituted with calls to start underscore items and finish items. There are primarily four types of UVM macros that can be executed on the default sequencer. The macros UVM underscore do underscore star. That you have to provide a UVM underscore sequence underscore item of object or a sequence. Sorry, you have to provide a UVM underscore sequence underscore item object or a sequence and internally. It will do the following. For, First, create the item if necessary using UVM underscore create. If you don't want it to create items, use UVM underscore send. Randomize the item or sequence. Call the start underscore item and the finish underscore item if it's UVM underscore sequence underscore item object. Call the start task FF is a sequence. It's a sequence. The UVM do execute this sequence on default sequencer with the item provided. UVM do will override on any default constraint in the inline values. UVM underscore do underscore pre execute based on the priority value. We used to use when running multiple sequences simultaneously. UVM do pre with execute based on priority and override default constraint with their inline values. UVM the star macros will identify if the argument provided is a sequence or a sequence item and will call start or start underscore item accordingly. Example, the sequence below will generate four items, randomize them to send to driver. See simulation result. The variable REQ is already declared and defined in the parameter for the sequence class. So REQ a type is of the type myData. The UVM underscore do underscore star macros will utilize a default inbuilt sequencer called m underscore sequencer. If you want the sequence to be executed on some other user-defined sequencer, you have to call UVM underscore do underscore on underscore stars macros as shown below. Structure. In the figure, each macro calls UVM underscore do underscore PRI underscore on underscore with to find the appropriate arguments. So note all the macros are coded using define with UVM and each of them calls UVM underscore do underscore on underscore PRI underscore with the appropriate argument. For example, like this, the simulation result. And next is UVM sequence start. How to execute sequences via start method and class hierarchy in UVM sequence. Note that you have to always pass the handle to a sequencer which should execute this sequence, whereas the other arguments are optional. Parent underscore sequence is often referred to the sequence from which the current one was called. This priority specifies a priority for the sequence. By default, it assumes the priority of the parent sequence and can be ignored for now. Call underscore pre underscore post will call the pre-body and post-body of the current sequence. Here's an example of how the start function has to be used and what happens in the background. The execution of a sequence in the figure and a simple sequence flow. To understand the sequence flow better, let us construct a simple sequence with a point statement in each of the above-mentioned methods. First, we will try to understand how call underscore pre underscore post arguments affect on the output. Within our test case, we'll call the start method of our sequence based on the score sequence based on the score SEQ. Note that the default value of core underscore pre underscore post argument of a start method is 1, and hence the pre underscore body and post underscore body tasks of the sequence will be called. As expected, the sequence executes pre body and post body tasks in addition to the body method. Now, let's apply 0 to core underscore pre underscore post argument and see that pre body and post body method are not executed. And simulation log. Takeaway. If core underscore pre underscore post is 1, then the pre-body and post-body method of the started sequence will be executed. Inherited sequence flow. The second argument to the start method is the parent, which might cause a confusion regarding the term parent used in the inheritance versus the parent used that start the main sequence. To try out an example, we will create a child sequence of base underscore seq with a print statement in each method and spawn that from test calls. In this case also, we get a similar result as before, where pre body and post body method are invoked because of the default value of the core underscore pre post argument in the star method. So it's clear that a parent argument simply specifies that the parent sequence from where the main sequence is started. Spawned sequence 4. Here, we'll start another sequence called child2 underscore seq from the body method in child1 sequence, with the rest of the code being the same. This example will demonstrate how the parent argument in start method can be used. It can be seen in the child2 underscore sequence also executed its own method after with the child1 underscore seq. Execution is resumed. Now, we'll supply the pointer to child1 underscore seq as an argument to the parent of the start method in child2 sequence. Now it can be seen that the pre-do, mid-do, post-do method of the parent sequence child1 underscore sequence has been called. The next is this is a file start. The do makers. Executing sequence makers. Use of sequence makers give added advantage and inline constraints. However, you lose the ability to control the invocation of a pre-body and post-body method in the executed sequence. It reduces the number of lines in our code by creating the item, randomizing and automatically calling the required tasks to the start in a given sequence or sequence item. In the previous article, we learned that all UVM do macros ultimately call the code defined in UVM underscore do underscore on do underscore pre underscore with. So let's just see how that is structured within UVM to get better clarity behind the process. If the object passed to this macro is a sequence item, then it creates the item and starts executing the item with the start item method core. The item will be randomized and the finish item method core. If the object if the object seq is not a sequence item, then the start method of a sequence is called. Note that core underscore PRE underscore post field over start method is set to 0, which means PRE body and post body method of a sequence will never be called when using these sequence macros. Execution flow is otherwise similar to when sequence is executed by the start method. Flow of execution as shown in the example, and then there is a execution of a sequence. Example: let's take some code we saw while using start method and now call UVM underscore do underscore pre with instead. Below the base sequence from which three child sequences SEQ1, SEQ2, SEQ3 are derived. And in SEQ1 below, notice that we have used UVM do UVM underscore do underscore PRE underscore with the macro with the empty constraint and no priority. We expect this to call the start method of SEQ2 and skip the pre underscore body and post body tasks. In the SEQ2, we kick off the another sequence SEQ3 using the same macros. In our final sequence, we don't do anything. The simulation results might look a bit fuzzy. The important things to note is that the PID-do, MID-do methods are called before a body task is called. Let's do simple dry run. Okay. Next is macros for pre-existing items. Sequence action macros for pre-existing items. Now we have already seen how to use UVMDo for a set of the macros. They automatically create a new object via calls to UVM create, randomize the item, and send it to a sequencer. If we already have a data object that we simply want to send a sequencer, we can use UVM underscore send. These are different variation to this macro, just like UVM underscore do underscore star. First, let's look into an example to see how UVM send is different from UVM do. Testbench environment is already in place, and we'll simply use a sequence to contain the calls to UVM underscore send and UVM underscore do. The main difference is that UVM underscore send will not create or randomize while UVM underscore will do both. And simulation log. Next is UVM virtual sequence. UVM virtual sequence. A virtual sequence is a container to start multiple sequences on different sequencers in the environment. This virtual sequence is usually executed by a virtual sequencer which has handles to real sequencers. The need for a virtual sequence arises when you require different sequences to be run on different environments. For example, an SoC design might have multiple different interfaces that might need to be driven by a different set of sequences on individual sequencers. Hence, the best way to start and control these different sequences would be from a virtual sequence. It becomes a virtual because it is not associated with any particular data type. And use of virtual sequencer. Note that the following from the example above. My underscore virtual sequence is derived from UVM sequence just like any other sequence. A handle called psequencer is created within the sequence via macro UVM underscore declare underscore p underscore sequencer and assigned to be run with my virtual sequencer. Each sequence is started on corresponding sequencer using the start method. Each sequencer is referenced by psequencer and which point to the virtual sequencer. Once a virtual sequence is defined, you can start this in your test as shown below. Without virtual sequencer, you can also put handles to individual sequencers with the virtual sequence and then would not need a virtual sequencer. The handles to sequencer within the sequence needs to be assigned prior to starting this virtual sequence. If you'd like, you can split the creation and assignment of a sequence into build and connect phase with my test. Next is UVM sequence library. Using the sequence library, a typical verification environment will have 100 of tests and the random seeds and configuration, which can be made simpler by having a variety of sequences to perform individual tasks. Now, you may create top-level sequences that can spawn off a smaller ones within each body task, or create a randomized way of calling multiple sequences. A cleaner way would be to use the sequence library provided by UVM as a UVM sequence library. As the name suggests, it keeps a track of sequences that are registered with it and calls them as a number of times in random fashion. You avoid object transition, sequence item, sequence space, sequence, and sequence library. That is class hierarchy of UVM sequence library. Let's take an example of three sequences, all derived from the same base underscore sequence class, as we have seen before. Here, the three are individual sequences without being nested inside each other. Now, we need to create a custom sequence library which should be derived from UVM underscore sequence underscore library. Note that you have to call the macro UVM underscore sequencer underscore library underscore utils macro to define the infrastructure needed to define extension to the UVM underscore sequence underscore library class. Each class, itself a sequence, can then be started independently on different sequencers or different phases of the same sequencer. You can create an instance you can create an instance of this sequence library in a test or another sequence, configure it, and add the required set of sequences to the library. A good way to start a sequencer to execute sequences from this library is to make it a default sequence. Random sequences are assigned to the sequencer by the library. Add underscore type-wide underscore sequence function can be used to add sequences to the library. In this case, the minimum number of iterations done by the sequencer is set to 5 and maximum 10. Next is UVM sequence arbitration. The UVM sequence arbitration. When multiple sequences try to access a single driver, the sequencer that is executing sequences schedules them in a certain order through a process called arbitration. The sequencer can be configured to grant driver access to certain sequences over other based on certain criteria as arbitration modes. Example: to understand the different modes of arbitration, let's first build a test containing an environment with a sequencer and driver. Note that the sequences do not require driver access and execute sequence items using start items and finish items do not have to undergo arbitration. So, if multiple plain sequences are started on a sequencer, they will be executed in parallel. 1. Data class. The class called base underscore class represents the data object will be sent to be the driver so that it can convert this into protocol level pin toggles at the DUT interface. This class definition is kept simple for our purpose to illustrate the arbitration scheme. The driver. Assume a driver accept to a data object of type base packet and toggles pins of the DUT. 3. Environment. The environment class instances a sequencer and a driver and makes the connection between them. 4. Sequence. The sequence class called sequence and a base underscore seq creates a data packet and is executed by the sequencer defined above. The data packet will be sent to the driver and will be blocked until the driver calls item underscore done method. Since the multiple instances of this sequence will be started on a single sequencer, a variable called sequence underscore num is declared to distinguish between the sequences. The address of a packet is also made unique to identify which sequence is responsible for sending data through the driver. 5. Test. A base test class is defined below that builds the environment and all sequences. It also has an additional function to display the current arbitration scheme of the sequencer with the environment. Based on the arbitration scheme, the sequencer uh, follows a certain of orders of granting access to all sequences to the driver. UVM underscore SEQ underscore ARB FIFO. This is the default arbitration mode where the UVM sequencer starts them regardless of their priorities. Without priority, system log, and then with priority. Let's add some priorities to the sequence when they are started on the sequencer and see how they behave. Note that the priority do not take effect in the UVM underscore SEQ underscore ARB underscore FIFO arbitration mode. The UVM underscore SEQ underscore ARB underscore random. In here, the sequencer will randomly start sequences regardless of their priorities. Without priority, system log. With priority. Let's add some priority to the sequence when they are started on the sequencer and see how they behave. Note that the priority do not take effect on the UVM sequence. Okay. UVM underscore SEQ underscore ARB underscore random arbitration mode. The UVM underscore SEQ underscore ARB underscore strict underscore FIFO. This mode will always grant the sequence with the highest priority first. Multiple sequences with the same priority will be arbitrated similar to a FIFO. For this test, let us increase the number of sequences just to have multiple sequences on the same priority. Without priority, Theta log is the same as the UVM sequence UVM underscore SEQ underscore ARB underscore FIFO arbitration mode when no priority are specified with a priority. Let the priorities affect up in UVM underscore SEQ underscore ARB underscore straight underscore FIFO mode. UVM underscore SEQ underscore ARB underscore straight underscore random. This mode will always grant the sequence with the highest priority first. Multiple sequences with the same priority will randomly picked. For this test, let us increase the number of sequences just to have more sequences on the same priority. Without priority, we'll note that this is similar to UV underscore SEQ underscore ARB underscore random mode when there are no priorities. With priority, note that M underscore SEQ underscore 1 through M underscore SEQ underscore 4 that have the same priority come out in random order. Compare this UV underscore SEQ underscore ARB underscore straight underscore FIFO mode where these sequences came out in a FIFO order. UVM underscore SEQ ARB weighted. There is a higher chance to picking higher priority sequences in this mode. UVM underscore SEQ underscore ARB underscore user. If none of the above modes are satisfied your requirement, then you can create a user-defined arbitration scheme. All you need to do is to create a new sequencer extended from UVM underscore sequencer and define each user underscore priority underscore arbitration function. Thank you for your time for the stimulus generation. Thank you.